Why are brittle materials so strong in compression? Imagine trying to crush a glass or break a ceramic plate with your hands. You might think they would shatter easily, but in reality, they can withstand a lot of pressure from squeezing. This is because brittle materials are surprisingly tough under compression. They resist being pushed together because their atomic bonds are very strong. When you press on them, the atoms are forced closer, and these bonds hold firm, preventing deformation. But if you pull or stretch them, cracks tend to open up easily, leading to failure at much lower stresses. Brittle materials mainly break by fracturing rather than bending or stretching. When compressed, tiny cracks inside these materials tend to close up. This prevents cracks from growing and stops the material from breaking apart. Think of it like pressing on a sponge. The cracks inside get squeezed shut, making it harder for the sponge to split apart. In contrast, pulling on the sponge makes the cracks open, causing it to tear apart easily. That's why brittle materials are so strong in compression but weak in tension. In failure modes, compression often causes axial splitting, where cracks form parallel to the load. These cracks releases energy and cause the material to split apart along specific planes. Sometimes, shear fractures happen, especially if the material is confined or under high pressure. The presence of lateral pressure can even change how these materials fail, making them break in different ways. From a fracture mechanics point of view, brittle materials fail when the stress at the tip of a crack reaches the material's molecular cohesive strength. Under compression, the stress at crack tips is reduced or counteracted, delaying fracture. This is why they can support loads several times higher than their tensile strength. This is why materials like ceramics, glass, and concrete are used in construction and manufacturing. They can support large compressive forces without bending or deforming. But if tensile or bending stresses occur, these same materials can suddenly crack or break. Knowing this helps engineers design safer structures by avoiding tensile stress concentrations and making the most of their compressive strength. When brittle materials do break, it's usually because of tensile or shear stresses, not compression alone.